Welcome to week 6, module 26 of Database Management Systems course in IIT Madras online BSc program. We have been discussing about different aspects of the design of relational databases, particularly focusing on a complete mathematical framework based on the dependency theory. And in the whole of last week, we did cover various aspects of it, starting from the basic notions of good design at multiple places, the theory of functional dependencies, different properties of functional dependencies, algorithms for functional dependencies, and characterization of lossless join and dependency preservation, which are key properties for having a good decomposed relation. In this week 2, we will continue on that, developing that, and in the current module, I will just take you through some of the initial normal forms of representation of relational schemas and how are they important in our design. So, we have talked about a little about normal forms earlier when we talked about the first normal form. The whole idea is it is kind of a refinement technique or a standardization technique of organizing data in a database, which satisfies some of the key properties. Right? Now, we have already discussed that there is the reason we need to normalize is normalization actually gives us good decomposition. Good decomposition gives us minimization of redundancy. Minimization of redundancy means removal or minimization of anomalies. So, that is basic structure of why we will have to normalize or why we will have to decompose, we have already discussed. So, we can say in one word that the goal of normalization is to eliminate redundancy of data, and also to ensure that the data dependency is done in a sensible manner. Here are examples of anomalies. We have already discussed this. These are little different examples. So, you can just go through and recap on the notions of anomalies, or you can go back to the earlier module and check on that. There is possibility of insertion anomaly, deletion anomaly and update anomaly, and we will have to avoid all of that. So, the process of doing that is decomposition, as this tree shows, that you start with the original schema and you decompose it into smaller schemas, and you do it in a way that the smaller schema satisfy some of the desirable properties. But it may not be enough for a particular relation, and if it is not enough, if you still have redundancy, then you may have to put additional conditions, additional properties and decompose it further, and this goes on. So, in this tree we have shown up to the third normal form. You start with the original schema. If all relations in that is not in the first normal form, you put them in you decompose and put them in the first normal form. We have shown examples of how to do this. If they are not in the first normal, if they are in the first normal form and still have redundancies, you would consider putting them in the second normal form. We will discuss what it is. If there is redundancy still, you will put it in the third normal form and so on. Now, as you decompose, it is critical that you maintain two properties. The first property is absolutely essential, that you have lossless join. In the modules last week, we have discussed in depth about it, that it should be possible to reconstruct the original data. And the second property is dependency preservation, that is, in terms of the decomposed relations, I must still be able to check for all the functional dependencies or all the different forms of dependencies without actually computing a join of the data. We have discussed this as well. So, with this we go into introducing the normal forms, specifies a set of conditions that the relational schema must satisfy in terms of its constraints. The common normal forms are first normal form, you already know that. You have second normal form, you have a third normal form, and so on. Informally, it is more often that the designers would use the third normal form to normalize a database. So, if you hear that this is a normalized database and nothing specifically mentioned, then you will know that this is a third normal form normalization. But these are not the only forms of only normal forms. You have already had seen Boyce code or BCNF normal form. Here are some more like elementary key normal form, Boyce code you have seen, multi-value dependency and fourth normal form, fifth normal form, sixth normal form, and so on. Obviously, we will not have time to discuss all of them, but the highlighted ones BCNF and 4NF also we will discuss in a later module, because it needs some more of the functional dependency theory, particularly the 4NF, and first, second and third normal form can be understood totally in terms of the functional dependency theory that you have already learned. The first normal form, what is the basic criteria? That underlying domain contain atomic values. Right. Now, we had been very explicit to say that every value has to be atomic and no attribute can be multiple valued. In generality, often these two are taken together to mean atomic value, that if a value is atomic, it means that it is indivisible. So, if there can be multiple values in the same field, then they are seen as if there are different components of the value and therefore not atomic. So, more often people do not mention the two conditions separately, people will say that it contains atomic values. So, there is a relation here, which on the left has multi-valued attributes, the course name, the courses that the students are attending, and on the right you have removed that and made that into a 1NF form, even though we know that this is not very desirable, because your primary key is now changing from SID to SID and SNAME. We have discussed these. Now, let us take a different example. We were discussing this example earlier too in terms of lossless join. So, you have a supplier relationship with supplier ID, status, city, product ID and quantity. Every city has a status, and on the right what you see here is these are the FDs basically. So, we say that SID uniquely determines city, supplier, given the supplier you know the city, given the city you know its status, given the SID and PID, supplier ID and product ID, you know the quantity. Right. So, this is instead of writing it down, this is just shown in terms of a diagram, people often do that. Now, naturally this this representation, this is in 1NF, because it does not it has only atomic values, but it has several redundancy and possible problems. For example, if I delete this record S3, then the information that Rohtak is a city and its status is 40 is going to get lost, because that is the only entry for Rohtak. If we cannot insert a supplier S5 who is located in kernel until the supplier has supplied at least one part, because you can see that part is a PID is a attribute which is part of the key, right. So, we have insertion anomalies. If a supplier S1 moves from Delhi to Kanpur, then it is difficult because there are already 4 instances, there could be more. You have to remember to change each one of them, update anomaly. So, this is these are the things which make which tell us that 1NF is not enough. Just having atomic values is not enough for this. So, if we just look at this in the functional dependency perspective, then we see that if x determines y is a non-trivial functional dependency over R, where x is not a super key of R, then there will exist redundancy, because x is not a super key. So, x can be duplicate, as you can see here, x can be duplicate, and if x determines y. So, if x is duplicate, y can also be duplicate. But if it is a super key, then it will not be able to duplicate. So, you will have this, though y can still duplicate because x determines y. So, obviously, y has no uniqueness here. So, these are things which, if they exist, will cause redundancy and the corresponding anomaly. So, we try to tighten our belt. We say we have a second, we introduce a second normal form. So, these typically most of the normal forms are hierarchical, that is, the higher normal form always is satisfying the lower normal form. So, you say that a relation R is in second normal form 2NF if first it has to be in one normal form, that is atomic values. Second, it contains no partial dependency. This is a new term we are defining, this is a new concept or refinement that we are putting in. What is a partial dependency? Let us try to see. Suppose I have a relation R with x, y and a 3 sets, where x is a key, candidate key. Y is a proper subset of the candidate key, right? Y is a proper subset of candidate key, right? Not necessarily of x, but proper subset of candidate key. And A is a non-prime attribute. What is a non-prime attribute? I mentioned this in some in terms of your practice problem sets. A prime attribute is one which belongs to some key, some super key, and a non-prime attribute is which does not belong to any, right. So, A is a non-prime attribute. So, if y determines A holds in R, if y, so y is a subset of a candidate key and A is no member of any candidate key, right. If y determines A holds, then we say that it is a partial dependency. Two conditions: y is a proper subset of a candidate key and A is a single or multiple non-prime attributes. This is the notion of partial dependency. Let us take examples to understand the consequences of this. This definition is nothing great, but the consequences is what we have to understand. What intuition that did. So, let us take a simple example. I have a student relationship which has student ID, student name and course name, which is already in 1NF, right. We have seen where you have on the diagram on right, on the diagram here, this is your, you can see these are the FDs. That is, student ID decides student S name and student ID and course ID together is a key, right. Now, is there an anomaly? Obviously, there is anomaly. There is possibilities of anomaly because you have multiple entries of the student's name, right. So, these are the functional dependencies as you have written over. Of that, if you see, look at this SID, this one. This is a partial dependency. How do I say? SID is a subset of a key, first condition, and SNAME is not a subset of, is not a member of any key, that is, it is a non-prime attribute. Right. So, this is Y as we wrote in earlier, and this is A as we wrote earlier. So, this is a partial dependency. Now, because of that, see, if the left hand side of this was a key, then what would have happened? It would not have been possible to have duplicates on that, and therefore, your SNAME would not have been replicated number of times. The student's name would not have been replicated a number of times, but it is not. So, what is happening is SID has multiple instances in a particular instance of the database, because it comes with different C name, giving it the uniqueness, and for each instance of identical instances of SID, the SNAME will get repeated. If SNAME were a part of the key, it would not have happened, because it would not have been possible to have multiple identical values of on it. Right. So, that is the partiality whole about. So, that is the two sides people have very nicely tried to bind that. On one side, on the left hand side, it is a subset of the key set. So, it can be occur in multiple numbers, and on the right it is not a member of any key set, is a non-prime attribute. So, it can replicate. Now, obviously, this can be very easily handled by doing a normalization. What you do is simply put this together and you put this together, right, because you will have to have the common attribute SID. So, here on the left in R1 you do not have any redundancy, in R2 either you do not have any redundancy. SID is a key on R1. So, you can see that and R1 intersection R2 is SID. So, you can easily see that the lossless join condition is satisfied, and now the dependencies are this dependency, your dependencies have now become, this is SID determining SNAME, and this is SID CNAME determining R2, that is both are required, right, trivial dependency. So, given that, your dependencies will get preserved. There is no case of partial dependency remaining. So, this is in 2NF, this is a lossless join and is dependency preserving. So, certainly, this is a better design than what we had earlier. The supplier case again you can see. So, you can see that well, with the supplier, these are the dependencies that we have, and therefore, I have partial dependency in terms of say city, because city is a non-prime attribute and the left hand side SID deciding city is a part of the key, not a key by itself. Similarly, the other one is also a partial dependency. So, I can easily decompose them by keeping this on one side and keeping this on the other side. Right. this is the decomposition, and the redundancy that we had is getting removed through this process. Right? Now, the question is, does it still have some redundancy left? You will have to check for that information. Now, we have seen that if we let me just go back once more. Now, if you see, I have not created the instance here, but if you see that SID decides the city, city decides the status, and therefore, SID decides the status. So, what you will have here is you have, given the SID, which is the key, you will have a unique city, and therefore, you will have a unique status. Right? So, that is how basically your redundancy is managed in the 2NF here. Now, going forward, let us the next is third normal form. If you have redundancy left after the second normal form, you go to the third normal form. Third normal form has evolved over a period of time through independent work. So, the first two definitions, which I will not go through, is just more for reference. One in 72 and another is in 82 have actually defined third normal form, but using different other notions. The simple third normal form statement, which is accepted today, is simply saying that it is in second normal form and does not have a transitive dependency. This is a simple thing that we say. Now, putting it in detail is there is no trivial dependency, A subset of X. X has to be a super key or A has to be a part of the candidate key. Either of these has to happen. And with that, we actually have that every 3NF relation is also naturally in 2NF. So, here we talk about transitive dependency. A transitive dependency is a functional dependency which hold by virtue of transitivity. Right. The transitivity can occur only in a relation that has 3 or more attributes, because A determines B, B determines C. So, if we have 3 attributes A, B and C, or this could be distinct collections also, need not be just attributes. Then let us say that A determines B, B does not determine A and B determines C. Then the functional dependency A determines C, which come from the first and the third by the transitivity of Armstrong's axiom, is known as a transitive dependency. Right. Mind you, this second condition is important for transitive dependency, because if A determines B and B determines C, then it necessarily means that these are equivalent attributes. They are strongly tied together. So, it is not a case of, because then B determines C is also A determines C anyway. It is not happening just because of the transitivity. So, an example, say you have a functional dependency that book determines author nationality, assuming that the books have one author, right, otherwise it will not hold. Book determines author and the author's nationality. So, what we can say is book determines author naturally. Author does not determine book, because an author may have written multiple books. Author does not determine book. but author determines author nationality. Right? The author will determine the nationality obviously. So, book determines author nationality is a transitive dependency. Right? So, this transitive dependency, why did it occur? Because there is a non-key attribute author, right, which is being determined from, which is determining another non-key attribute author nationality. One non-key attribute author is determining another non-key attribute author nationality, and that is where the basic problem of the transitive application happens. So, if we get back to the earlier situation, earlier example, this is one and this is the other, two functional dependencies. Now, that leads us to city SID determining status, which is a transitive dependency, because you do not have, you have SID determining city, but you do not have city determining SID. Naturally, multiple suppliers can be there in the same city. Okay. So, there is possibility of anomalies here. So, what we will do is we will normalize, say, based on, we will break this transitivity. So, how do we do that? We do SID city and we do city status, put them in separate buckets. As you do that, SID is a key of the SC component and city is the key of the CS component. CS is the common attribute, it is the key of CS. So, city will ensure that the join is lossless. These are in 3 normal form, because it is in 2 normal form and there is no transitive dependency, and you can easily see that this preserves the dependency, because SC can check for SID determining city, CS can check for city determining status, and therefore, by closure SID determining status will get checked as well. Another, a relation department advisor. So, you have SID student name, instructor name and department name, where student ID and department name decides the instructor, which is obvious, and the instructor name decides the department name. So, there are 2 candidate keys for this relation. One is SID and department name, because it determines IID, and SID and IID, because that will determine the department name as well. So, there are 2 candidate keys. Now, is this relation in 3NF? Let us check the dependencies. SID department name decides IID, SID department name, department IID. So, SID department name is a super key, no problem. So, this is fine. IID change determines department name, but here IID is not a super key, but department name is a part of a candidate key, part of the candidate key here. So, this relation is in 3rd normal form and we are happy to go with it as a 3rd normal form relation. Now, before we close, let me just show you that this 3rd normal form relation may also have redundancy. I mean, just to make the writing simpler, I have used some coding, J for SID, L for IID and K for department name. So, this is how it looks like. SID and department names determines IID, JK determines L, and L determines K, IID determines department name. And these are different entries which satisfy. You can see that there is no entry where J and L are same, and k is different. So, that is satisfied. L determines k. So, whenever I have L 1, I have this value as k 1. Right. So, this is fine. Now, there is of course, this relation is a third normal form, but there is repetition of information, as you can see here. And suppose there is an instructor who is not supervising any student right now. So, there is no SID. So, but that instructor needs to have the department name. So, if I have I 2 whose department is K 2, but there is no SID, there is no student being supervised, then I have to use null values for this. So, well, this is, as we said, is came in third normal form, but still there are problems that will keep on hitting us. We will have to do more in terms of them. So, in this module, we have introduced the basic notions of three critical normal forms, particularly the third normal form, because it is often very often that it is not enough to just to do the first or second normal form. And we will see subsequently that there is further reasons to focus more on third normal form, because as we had seen earlier that decomposing a relation in Boyce code normal form, though it guarantees lossless join, it cannot guarantee dependency preservation. We had shown examples of that. But for third normal form, we will show an algorithm, will show a way so that any relation can be decomposed into third normal form, which is both lossless join as well as preserves the dependency. The other reality of third normal form being very prevalent is the fact that the subsequent normal forms are quite more difficult to model, identify their requirements through multi-valued dependencies and so on, that we are going to talk of in the real world. And as it happens that most of the situations that arise, or a large number of the situations that arise in the real world, gets very well addressed with the third normal form. So, we will have to focus some bit more on the third normal form. Remember that a third normal form relation is in a relation which is in second normal form, but does not have partial transitive dependency. A second normal form is in first normal form, which does not have partial dependency. So, third normal form is atomic, does not have partial dependency and does not have transitive dependency. With those, let us close the module here today, and thank you very much for your attention. We will continue this in the next module.